Well, it's a pretty old CBSE AIPMT 2007 question, but still we are taking it up from one-dimensional motion so that we can have some conceptual clarity. It is given that a particle is moving along one-dimension x-axis with an acceleration f, which is given as f is given for you as, you can write down the data, f naught of 1 minus small t by capital T, where f naught and capital T are constants and small t is variable. At t is 0, particle has a 0 velocity. We will come to that a little later. In the time interval between t equal to 0 and the instant when f equal to 0, what is the particle velocity is? So the first thing that I need to understand is I need to get velocity from this, right? Given that it's an acceleration can be written like rate of change of velocity, dv by dt. That is given as f. That is equal to f naught of 1 minus small t by capital T. So if you want dv, you have to take this dt to the other side. So dv equal to f naught of 1 minus small t by capital T into dt. This is change in velocity, small change in velocity. You want the total velocity in a total time t. So to get that, we shall integrate that equation. So what we shall do is now to get total velocity, we shall integrate that equation. What we have got just now. This is the equation. So integral of dv equal to integral of f0 1 minus small t by capital T into dt. So you can rewrite this as integral of differentiation of v is v itself. This can be written like integral of f0 multiply with f0 dt minus f0 small t by capital T dt. That's also integral. That implies you get velocity as v equal to f0. Integral of differentiation of time is time itself minus f0 by capital T is constant. Integral of t power 1 dt, we have a formula. Integral of x power n dx equal to x power n plus 1 by n plus 1. That is t power 1 plus 1 by 1 plus 1. That is t square by 2. Square by 2. Plus there will be a constant always called an integration constant. We don't know the value of this integration constant. How can we get that? We don't know the value of that constant. To know that, he has given a condition for you that yet this is the condition given for you. The particle at t equal to 0 has 0 velocity. So you got an equation for v already. Yet t equal to 0, find v0. f0 into t, as t becomes 0, the term becomes 0. Here also there is a term t, so that also becomes 0 plus c. That is given as 0. At t equal to 0, velocity is 0. That means this constant is 0. Right? Everything is 0 means this constant has to become 0. So v can be rewritten as f0 into t minus f0 into small t square by 2 into capital T. That's the value of v. Now he has given that at t equal to 0, what is the velocity? We have already found. And when f equal to 0, what happens when f equal to 0? We have got an equation for f already. This is the equation for f, right? That's right. What happens when f equal to 0, right? Let's write that. It is given that we found that f equal to f naught of 1 minus small t by capital T. When f equal to 0, these two terms has to be equal to 0. But I definitely know that f0 is not equal to 0. It has some value. So 1 minus small t by capital T has to be 0. It implies 1 equal to small t by capital T. It implies small t equal to capital T. So when f equal to 0, small t becomes capital T. So we can get the value of that v x a f equal to 0 to t equal to 0 as, put in the place of small t, put a capital T. Vx equal to f0 into capital T minus f0 into the place of small t, capital T, by 2 into capital T. 1 t gets cancels. So what is remaining is f0t minus f0t by 2. If we subtract the same terms, we get f0t by 2. So the answer of this, which I have missed in taking the options, has to be this. This is the answer. Like, I have forgotten to take the options on the screenshot, but I found that this answer is there. So that's the answer for the problem. Vx equal to f0t by 2. That's how we have to solve the problem. It's little lengthy, I understand, but you have to know the concepts so that you will be able to get that. Once acceleration is rate of change of velocity is one key concept. Integration has to be used. Integration formula has to be known. Conditions, what all given for you, are just substituted, and so that we can get to the answer. That's how we have to carefully solve the problem. Thank you for watching. If you are having any doubt on that, you can just put a comment so that I will respond to that. That's it. Thank you.